Hi guys, this is Mrs. Rooker. This is the video for 4.7a. Pause the video and try these review problems. They're a little tricky, so you can unpause them if you don't know how to do them, and I will show you how to do them. Alright, the first one, it says cotangent of x equals 0. What is cosine of x? So first off, we need to figure out what x would have to be if cotangent is 0. I don't really like dealing with cotangent. I'm going to change this to tangent of x, and then I'm going to make this 1 over 0 because cotangent and tangent are reciprocals of each other. Okay, but 1 over 0 is undefined. So we need to see when tangent is undefined. And tangent is undefined at pi over 2. So that means x must be pi over 2. So now we'll plug into cosine of x. We'll plug pi over 2 into there. And then cosine of pi over 2 is 0. So your answer should be 0 for that first one. All right, for number 2, when sine of x equals root 2 over 2, we need to find out what cosine of x would be. And it says that we're going to have 2 answers. So first things first, I want to see what x should be. And I'm thinking I'll probably have 2 options for what x could be in order for sine of x to be root 2 over 2. So I know that one of the options for theta or x is going to be pi over 4. Because sine of pi over 4 equals root 2 over 2. And then I know that it's also going to be, sine of the x is also going to be positive in some other quadrants other than just 1. I know that sine is positive in quadrant 2. So my other angle that x could be would be 3 pi over 4. So those are my options for x, and then I need to figure out what cosine would be at both of those locations. So I know cosine of pi over 4 is root 2 over 2. And then it's also root 2 over 2 for 3 pi over 4. Oops. But it's not going to be positive. Think about a smart trig class. Sine is positive in that quadrant, but cosine is not. So it's going to be negative root 2 over 2 for that quadrant. All right, the next one, tangent of x equals 1. So tangent of x equals 1 at pi over 4. And then think about a smart trig class. It's also positive in quadrant 3, so that's going to be 5 pi over 4. So that's quadrant 1 and quadrant 3. And now we need to find sine of both of those angles. So sine of pi over 4 is just root 2 over 2. For 5 pi over 4, it's also root 2 over 2, but we need to check the sign. So that's the third quadrant, and sine is negative in the third quadrant. So our answer is going to be negative for that one. All right, the goal for this lesson is to use inverse trig functions to find principal values. Know the principal values for each trig function. Use Pythagorean theorem to find specific trig ratios. When we talk about principal values, we talked about this in the previous video, but we're talking about basically the quadrants that inverse sine can exist in. So for sine, this will be in quadrant 1 and quadrant 4. And some teachers draw kind of a visual that it's in these 2 quadrants. So quadrant 1 and quadrant 4 for sine. And that's the same with tangent, 1 and 4 also for tangent. Different for cosine. Cosine principal values will be in quadrant 1 and quadrant 2. And for sine, sorry, I should have written this when I first wrote it. Quadrant 1 and quadrant 4 is going to be, all the values are going to be from negative 90 to positive 90. Or if you're writing this in radians, this is negative pi over 2 to pi over 2. And that's going to be the same for tangent, except it's not included because pi over 2 and negative pi over 2 are going to be undefined for tangent. All right, and then cosine is from 0 to pi, or 0 to 180 are going to be the values that come out when we do inverse cosine. All right, so now we're going to practice finding some values. The big thing that you need to know for this is you start from the inside out. Inside out. All right, so we are going to start with inverse sine of 1. I'm going to rewrite this. Inverse sine of 1 just means sine of some angle theta equals 1. So sine of what will give us 1? And if you know your unit circle, you'll remember that sine of pi over 2 equals 1. So this part just becomes pi over 2. It could also give us different values, but remember for sine, we're only looking to be in the first quadrant or the fourth quadrant. So since pi over 2 is in that first quadrant, or really it's between pi over 2 and negative pi over 2, we choose that value. All right, now we haven't dealt with the cosine yet though. So now we're just doing cosine of pi over 2. So that's just this cosine that we hadn't dealt with yet. And then cosine of pi over 2, again, if you remember your unit circle, cosine of pi over 2 is 0. All right, moving on. Now let's start again on the inside. I'm going to rewrite this as cosine of some angle theta, I don't know what that is yet, equals root 2 over 2. I know that cosine of 45 is root 2 over 2, or pi over 4. So I know that inverse cosine of root 2 over 2 equals pi over 4. And now I still have to deal with the sine. And then sine of pi over 4 is root 2 over 2. That will be my final answer. All right, now we'll start with the inside. I don't love dealing with cosecant, so I'm going to change this to a sine of some angle. But if I'm changing cosecant to a sine, I have to do the reciprocal, since cosecant is the reciprocal of sine. So instead of 2, it's going to be 1/2, the reciprocal of 2. All right, and then I need to solve for what theta would be. Sine of something equals 1/2. The answer there is pi over 6. Sine of pi over 6 gives us 1/2. And then I still need to take tangent of pi over 6. Hopefully you remember that tangent of pi over 6 equals root 3 over 3. All right, now we're getting into some negatives, fun stuff. So this is where we have to be careful about what quadrants we're dealing with. All right, so sine of some angle that we don't know what it is yet equals negative 1/2. Well, I know that sine of pi over 6 equals positive 1/2, but I want it to be negative. So we need to think about the principal values for sine. We know that sine is going to be, if we look over here, is in quadrant 1 or quadrant 4, which means from negative pi over 2 to positive pi over 2. So we're going to be looking in quadrant 1 or quadrant 4. All right, and I know that pi over 6 would give us positive 1/2, so negative pi over 6 will give us negative 1/2. So my answer is going to be negative pi over 6. And that is located in quadrant 4, so we're good to go. You just wouldn't want to pick something that is in quadrant 3 or quadrant 2. All right, so that's our answer for that inside, for the inverse sine of negative 1/2. Now we need to find cosine. We still haven't dealt with the cosine on the outside. So cosine of negative pi over 6, I know that cosine of pi over 6 is root 3 over 2. So cosine of negative pi over 6 equals cosine of positive pi over 6. So we're going to be dealing with some reciprocals here. Again, I don't like dealing with secant, so I'm going to change this to cosine of some angle equals, and then I just need to do the reciprocal of negative 1. Well, the reciprocal of negative 1 is still negative 1, because negative 1 over 1 is the same as negative 1. So we need to find cosine of theta equals negative 1. And that's going to be pi. Now we still have to deal with cotangent. We haven't dealt with that yet. I know, and hopefully you have memorized, that tangent of pi is 0. Well, cotangent is going to be the reciprocal of that. So that's going to be 1 over 0, which is undefined. Oops. So our answer should be undefined. Next one, again, start on the inside and rewrite this as sine of some angle theta, we don't know that yet, equals negative 1. All right, and if you don't remember, you can always kind of visualize your unit circle. Sine, remember, is your y values. Your y is going to be negative 1 down here, which is going to be root 3 over 2. But we have to be careful here. Remember that sine has to be between negative pi over 2 and positive pi over 2. Those are our principal values. So 3 pi over 2 isn't going to be an acceptable way to write this answer. But remember, this here is the same as negative pi over 2. So my answer for this little part is going to be negative pi over 2. Right, and then we need to find sine of that. And sine of negative pi over 2, we're already there with this angle here, is going to be negative 1. All right, next one, start on the inside. Sorry, these got crossed out. Just ignore that. Cosine of pi over 6. So I'm going to start by just doing the inside, cosine of pi over 6, which is going to be root 3 over 2. But then I still have to do inverse cosine of that. It's going to take us right back where we started at pi over 6. All right, another one similar to that, but we're going to get something a little different. We're going to start with cosine of 7 pi over 6. Cosine of pi over 6 should be root 3 over 2, but then we need to determine if it's positive or negative. This would be in the third quadrant. A smart trig class. T would be positive in that quadrant, but cosine is not, so our answer is going to be negative. And now we need to do inverse cosine of that. So I'm going to draw a picture of this. I think it makes a lot more sense to me when I have a picture. A, smart, trig, class. I see that I have a negative here, and it's cosine. So my only options for negatives for cosine are going to be quadrant 2 and quadrant 3. Okay. But remember, when we're doing inverse cosine, we're only allowed to be in quadrant 1 or quadrant 2. That's where the principal values are. So we've got to be in quadrant 2, and we're trying to do inverse cosine of root 3 over 2. So I'm going to rewrite this as cosine of some angle theta equals root 3 over 2. And I know that cosine of pi over 6 equals root 3 over 2, so I know I'm going to have a pi over 6 as a reference angle, but I can see that it has to be in quadrant 2, otherwise we wouldn't have had this negative if it was in quadrant 1. So to be in quadrant 2, this is going to be 5 pi over 6. So we're just kind of working backward on these. This one, always start on the inside. Let's take just sine of negative pi over 4. Again, I think it helps to draw these sometimes. Sine of negative pi over 4, that's going to be in this quadrant here. And our answer is going to be root 2 over 2. And then we have to determine if it's positive or negative. A, smart, trig, class. It's going to be negative in that quadrant. So we have negative root 2 over 2. And then we need to find inverse sine of that. So inverse sine of negative root 2 over 2. We know sine will either be in the first or fourth quadrant for inverse sine. And then root 2 over 2 is going to be a pi over 4, but in order to be negative, it's going to have to be in the fourth quadrant. So this is going to be negative pi over 4, which basically just took us back to where we started. So you might notice that you could have essentially just canceled those two out, and we would have been left with negative pi over 4. But be really, really, really careful not to do that every single time, because you'll see on the next one that it doesn't always work out like that. So let's draw this one. We have 7 pi over 4, which is in this quadrant here. Sine of 7 pi over 4 is going to be root 2 over 2, but since it's in the fourth quadrant, it's going to be negative. And now we need to take the inverse of that, which is just going to be sine of some angle theta equals negative root 2 over 2. But remember, when we're taking inverses of sine, we need to be in quadrant 1 or quadrant 4. We need to be between negative pi over 2 and positive pi over 2 is how we need to write our answers. All right, so we're going to be in the fourth quadrant since it's negative, so our answer is going to be negative pi over 4. All right, so you might have noticed on, let's scroll back a little bit. On number 7, we could have just canceled these two out. Our answer ended up being pi over 6. But then on number 8, it didn't work out like that. We couldn't have just canceled these out because we got a different value on our answer than we had originally. So right here we have some rules. If you want to be able to sometimes cancel out sine and cosine, you need to follow these rules. You will be able to cancel out cosine and cosine of x if your numbers are between 0 and pi inclusive, meaning including 0 and pi. And the reason is because your principal values are between 0 and pi for cosine. And then the same will go for sine and cosine, except our principal values for sine and cosine, sine and tangent, inverse sine and inverse tangent, are not 0 to pi, they're negative pi over 2 to positive pi over 2. So memorize where your principal values are. For cosine, they're between 0 and pi. For sine and tangent, it's between negative pi over 2 and positive pi over 2. I messed something up though. This should have been parentheses, not brackets. Remember, tangent does not exist at pi over 2. So we have parentheses because that part is not included. All right, so that means on example number 9, we were allowed to cancel out the signs because of the fact that negative pi over 4 is between negative pi over 2 and positive pi over 2. But we weren't able to just cancel these out on number 10 because 7 pi over 4 is not between those two values. So be careful on that. If you're wanting to cancel stuff out, make sure your number is between the two values that give you your principal values. All right. These ones, however, if the inverse is on the inside, inverse on inside, then you're good to go. Meaning you can cross them out. So since the inverse is on the inside, I can cross those out and get y as an answer, no problem. Doesn't matter if I'm in between the values for our principal values. Okay, sorry, the computer's running low. Battery, these long videos. So those cancel. If the inverse is in the inside, we're good to go. We can just cancel. All right, find the exact value for each without using a calculator. Use x squared plus y squared equals r squared, which is Pythagorean theorem. All right, excuse me, sorry. All right, so we're going to draw pictures for all of these. So I'm going to start with sine, or inverse sine of 4 over 5. So I know that sine is opposite over hypotenuse. So I'm going to show that the opposite over hypotenuse is going to give us 4 over 5. So opposite is going to be 4. Hypotenuse is going to be 5. And then that's our theta, like always. This should be a right angle. We're always going to have right triangles here. And then I'm going to use Pythagorean theorem to find the last side of the triangle. A really famous or popular Pythagorean triple is going to be 3, 4, 5. So without even having to do Pythagorean theorem, you might remember that we've got 3, 4, 5 here. All right, and now that we know that, we can just move on to finding cosine using this triangle, or cosine of theta. Remember, cosine is adjacent over hypotenuse. So adjacent to theta is 3, hypotenuse is still 5, so our answer is going to be 3/5. All right. Why don't you guys try the second one on your own, and then you can unpause the video when you're done with that. You are not going to be in quadrant 1 because of the fact that you have a negative 12. And so we're dealing with cosine, so cosine is adjacent over hypotenuse. So the adjacent is going to be negative 12, so we're going to go in the negative direction, 12. But then the hypotenuse is 13. So this is negative 12, this is 13, and then we need to find this missing side. Again, this is a Pythagorean triple, the Pythagorean triple, 5, 12, 13. So this will be 5. If you didn't know that, that's fine. You would just have to use Pythagorean theorem and solve for the missing side. All right, and then since we're trying to find sine, remember that's theta, sine is opposite over hypotenuse, so opposite of theta is 5, and hypotenuse is 13. So your answer should be 5/13, or 5 over 13. Okay, on the next one, I don't love dealing with cosecant, so I'm going to change this, and just this little inside part is going to become sine, or inverse sine, of 1/3, since cosecant is the reciprocal of sine. So now I'm going to do, this will be in the first quadrant, sine is opposite over hypotenuse. So opposite is going to be 1, hypotenuse is going to be 3. And then this is not a pretty Pythagorean triple, so I'm going to have to use Pythagorean theorem. 1 squared plus, I'll call this b squared, has to equal 3 squared. B squared will equal 9 minus 1, so 8. Square root both sides. Root 8 reduces to 2 root 2. So that's the missing side of the triangle. And then we need to find tangent of this triangle. Tangent is opposite over adjacent. So opposite of theta is going to be 1 over adjacent, which is 2 root 2. Can't leave an answer like that. I need to rationalize the denominator. So I'll multiply top and bottom by root 2. End up with root 2 over 2 times 2, which is 4, which will be our answer. All right, last one. Let's draw a picture. Now we're going to go, sine is opposite over hypotenuse. So the opposite is going to be -1, so I'm going to be going down 1. But then the hypotenuse is 5. And I need to find the missing side by using Pythagorean theorem. 1 squared plus b squared equals 5 squared. B squared will equal 25 minus 1, which is 24. Square root both sides. B equals, break down root 24, let's see, 2 root 6. So this side will be 2 root 6. And then we're doing the reciprocal of sine. So instead of adjacent, instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. Hypotenuse over opposite is going to be, whoops, this was supposed to be -1. Well, that was silly of me. We didn't even need to find this side because we're dealing with hypotenuse over opposite. So 5 over -1, which is just going to equal -5. All right, so definitely make sure it's necessary for you to find the other side before you find it. Last thing says check each of the above with your calculator. So each of these can be done with the calculator. You probably won't get exact values like root 2 over 4, but you can check and make sure that you did them right with the calculator. All right, that's it for today. Thank you guys.